Hi everyone. Welcome to my YouTube channel Next Generation Chemistry. Myself Hafizur Rahman. I completed my PhD from University of Hyderabad in Chemistry. On this YouTube channel, I will teach chemistry for JEE mains and advanced level, including NEET also. Today, I am going to start organic chemistry. So when organic chemistry will come, definitely we have to understand the IPC nomenclature, name of the compound. Here I will teach the IPC nomenclature very simple way. I will not go through the rules. Definitely I will follow the rules. If you read various books, you can find easily the rules, and according to the rules various types of example also. But end of the day we have to learn how to write the name of any organic compound. It may be simple or may be complicated, that you have to know. If we say organic compound, that simple thing, that hydrocarbon. So we'll start by hydrocarbon. Hydrocarbon. So what is the meaning hydrocarbon? That is very simple. Hydro means hydrogen, carbon. Those compounds are made by carbon and hydrogen. These are called hydrocarbon. So broadly, these are basically three types: alkane, alkene, and finally alkyne. So here, what are the difference? Alk, here also alk, these are common term. So difference is ANE, this is ANE, ENE and YNE. So when the term ANE will come, that means carbon-carbon single bond only. It indicates carbon-carbon single bond only. ENE, alkene, carbon-carbon double bond. YNE, carbon-carbon triple bond here. Through the molecular formula, only for acyclic cases, general formula CnH2n plus 2. This applicable for acyclic. Those are open chain. So carbon-carbon single bond, it may be open chain or cyclic. So this formula applicable for only acyclic or open chain, not applicable for closed or cyclic. In case of alkene, that will be Cn2n. Alkyne, CnH2n minus 2. So today's session will focus only alkane part, both cyclic and acyclic. So before starting the naming of the alkane, we need to understand the root words. If the number of carbon 1, the root word myth. Root word is myth. If number of carbon 2, eth. Number of carbon 3, prop. Number of carbon 4, that is but. 5, pent. 6, hex. 7, hept. 8, oct. 9, non. 10, dec. 11, undec. 12, dodec, and so on. So initially these are enough to write the name of the alkane part. Okay, now we will see the compound of alkane. Let's say C3. I told you the molecular formula, the general formula for acyclic alkane, that is CnH2n plus 2, where n is the number of carbon atom, where n that indicates number of carbon atoms. So number of carbon atoms in case of acyclic acids, so hydrogen should be 2n plus 2. Why this thing? Because in this chemical bonding chapter, we will learn the covalency of carbon. So that covalency of carbon is 4. So carbon always try to connect maximum 4 bond. Maximum 4 bond. Because valency of carbon is 4. So you have to fulfill 4 valency. So that's why here 2n plus 2. In case of carbon here, C3, C. Okay, you have to fulfill hydrogen. So maximum one carbon can bond 4, maximum 4 bond. So 3 here already 2, 4, here also 3. So 3, 6 plus 2, 8 hydrogen. Here we are discussing only alkane. It means carbon-carbon single bond. So what is the root word? 3 carbon prop. So the name of this simple compound, the name will be root word plus ane. So what is the root word here? Prop ane. That name will be propane. If I say, what will be the name? This compound. You have to check only if they provided the structure like this. They are not providing the molecular formula. If molecular formula like this, C4H10, that time you have to check. If they mention this is cyclic, acyclic, that you have to check. If it is acyclic, then you have to satisfy whether is it alkane, alkene or alkyne. If it is alkane, means definitely 2n plus 2, that n here 4. So that you have to satisfy. If it is satisfied, it means this is alkane. But here no need to satisfy. Only carbon-carbon single bond they mention. And you have to fulfill by hydrogen. So number of hydrogen here doesn't matter. You have to assume the rest of the all atoms should be hydrogen. You have to check carbon-carbon single bond, then it's okay. If it is all a single bond, it is definitely alkane. So 4 carbon, that but, root word, and ane. So these are the simple things. Sometimes this kind of thing, this thing. So when this type of problem, here you have to check is terminal carbon, is terminal, you have to consider carbon, and junction also carbon. So here definitely carbon carbon single bond, all are single bond. No need to satisfy here hydrogen. It's enough. That basically single bond only, that is enough to write the name. 1, 2, 3, 4, 5, 6, 7. So Hept ANE. So these are the very simple things. But we need to understand, or we have to learn complex system. So when we'll do the complex system, we have to follow certain rules and regulation. That rules and regulation we will learn through the example. Clear? Let's say this thing. CH3, CH2, CH, CH2, CH2, CH3. Here CH3. Now, first thing that we have to do, you have to identify the longest chain. Longest chain. So how do you identify the longest chain? If you start from here, 1, 2, 3, 4, 5, 6. 6 carbon here. If you go 1, 2, 3, 4, 5, this is less than 6. If you go 1, 2, 3, 4, 5, 4, that will be 4 carbon. So this is your longest chain. And this one will be substituent or branching. This will be substituent or branching. Now, longest chain, then substituent or branching. That substituent or branching, the numbering of the substituent or branching should be lowest numbering. So numbering, you have to start either from left side or right side. So if you say, if I start right side or left side, both are correct. This is not possible. Either left side it will be correct or right side. So next thing, that will be lowest number. Lowest number for branching or substituent. If you start from right side, the numbering 1, 2, 3, 4, 5, 6. Clear? But if you start from left side, 1, 2, 3, 4, 5, 6. So from left side, the branching number of carbon, that is third carbon. The position of this branching at third carbon. But in case of right side, if you start, the numbering of the branching at fourth carbon. So definitely you have to choose left to right. That will be the correct numbering. Right to left numbering, this is wrong. Now, when the branching or substituents are present, here only one branching. Sometimes we can see more than one branching also. It may be one or more than one also. So that first you have to write as a prefix. So normally we saw the simple thing root word plus ane, root word plus ane, root word plus ane. But here before this thing we have to write here as a prefix, that will be substituent or branching. Here we have to put the name substituent or branching. Clear? If the branching or substituent one carbon, single carbon branching, it means CH3, that name will be methyl. Root word meth, just YL, methyl. If C2H5, two carbon branching or substituent, that will be ethyl. 3 carbon, C3H7, that will be propyl, and so on, butyl, pentyl, hexyl, like this. Now we have to write the name here. So first thing, that basically this is the longest chain. Second, that numbering. So numbering should be start from left side. So third carbon methyl, that you have to mention the number, which position, third. So 3 methyl, then total thing, that 6 carbon, root word hex n. So in case of number and word, in between number and word we have to put hyphen here. Number, in between number, that will be comma. Okay, we can discuss another example. What will be the name? So what is the first thing that we have to do? That longest chain. 1, 2, 3, 4, 5, 6, 7. If you consider that blue color, that is the 7. Okay, that blue color 7 carbon. Okay, if I consider this one 1, 2, 3, 4, 5, 6, 7, 8, that red portion, if you consider red portion, that will be 8 carbon. So now we have to take decision which one will be the longest chain. That is called principal chain. So principal chain will be the red portion, that chain. First thing, that longest chain, that already we identified, that longest chain, 8 carbon longest chain. Now numbering. So if you start, and this one here as a branching or substituent, this methyl group as a branching or substituent. Clear? Now numbering. If you start from here, 1, 2, 3, third position, that methyl group. if you start from here 1, 2, 3, 4, 5, 6 position. So definitely the numbering from here 1, 2, 3, 4, 5, 6, 7, 8. Now what will be the name? Third position methyl, 3 methyl, then octane. That is the name. Clear? Okay. Now in this example, if I add here another methyl group, here another methyl group, then what will be the name? The red portion will be the longest chain, no doubt. There is no other way where you can get the longest chain. Definitely that red portion I marked here, that will be the longest chain, no doubt. Now here numbering. So if you start from here, that two branching here, one branching here, another branching here. So if you start from here, 1 to third position, 1 and fifth position. So third and fifth position. Clear? If you start from here, 1, 2, 3, 4, definitely they are getting more number. So lowest number, that will be the more priority. So 3 and fifth position, you can't start from here because here third position, first branching basically at third carbon and second that will be fifth. But here 1, 2, 3, 4, first branching will be at fourth carbon and sixth carbon next branching. So you have to follow from here. So third position and fifth position, two methyl groups are there. So 3 and 5, 3, 5, two methyl group. So that's why 3, 5 dimethyl here, dimethyl, because two methyls are there, that's why I written here dimethyl octane. Clear? Dimethyl octane. Okay, now the next example. So what will be the first thing that we have to do? We have to find out the principal chain, that is the longest chain. If I start from here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so 10 carbon. Is there any other possibilities to get 10? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. So that 10 will be the longest chain. So here the longest chain will be this thing. Red portion that I marked here, that will be the longest chain. Now the numbering, either it will be left side or right side. If I start from left side, that numbering 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Clear? But if I start from right side, that I use black color, 1, 2, 3, 4, 5, here 6, 7, 8, 9, 10. Clear? So definitely the numbering should be start from left side. So right side, that is wrong. So numbering right to left, that is wrong. Why? Because the branching, here two branching, one methyl here, another, that is ethyl group. So if we start from left side, first branching at third carbon and second branching fifth carbon. So third and fifth carbon, third plus fifth carbon. If I start from left to right, okay. But in case of right to left, that first branching sixth carbon and next, that is 8. So definitely the branching, that should be lowest numbering. If we have multiple branching, more than one branching, that is called lowest locant rule. So 3 plus 5, 8, here 14. So definitely we have to start from left side. So now what will be the name? So first we have to write the branching or substituent. So third position methyl. Here one methyl at third position. Here another ethyl. That is fifth position. Here another thing that we have to follow, that alphabetical order. Methyl and ethyl. Ethyl start from E, methyl start by M. So definitely ethyl will be more priority. So the name will be 5-ethyl, fifth position, that ethyl fifth position, because here 2 carbon, substituent as a 2 carbon, that's why ethyl. 5-ethyl, then 3-methyl, 3-methyl, and total carbon 10. So root word will be dec. So decane, DECANE. So that will be the name of this organic compound. Now if I change here, if I put here another methyl group, okay, see here another methyl group. So what will be the change here? Earlier it was 2 substituent group. Here methyl, third position and fifth position. Now third position, here also methyl group. Now we have to maintain the same numbering from left to right, or it will be changed right to left. That we have to check. If we start from left, that third position, sixth position and 8. Okay, sorry, third, fifth and 8. Third, fifth and 8. But in case of right side, third position, third carbon, then sixth, then 8. So that will be the number. Definitely more number here, more numbering. 9, 8, 17. So that is total 16. So this is the lowest number, 16 is lower number. So we have to start from left side. So numbering should be started from left side. Okay. So now what will be the name? The name will be according to this third and eighth position, 2 methyl group. So here ethyl group position same here. So 5-ethyl, 5-ethyl, and third and eighth, it means 3, 8 dimethyl decane. So that way we have to write the name. So few things that we have to remember. First thing that we have to identify the longest chain, then branching the numbering. So we have to do the numbering where the branching should be lower position, lower numbering. If we have multiple branching, that we have to check that way where we are getting the lower number, that is the lowest locant rule. And if we have different substituent or branching, let's say methyl, ethyl, propyl, butyl, so that time we have to follow alphabetical order. So alphabetically order definitely B, that butyl. If butyl is a substituent group, so butyl will be, we have to write first, then ethyl, then methyl, then propyl. So these are the things acyclic cases. Now we have to focus cyclic cases also. So cyclic cases, if we check the cyclic thing, here CH3, CH2, CH3. So this is acyclic. So what is the name? That name is, tell, propane. Propane. If I connect these two terminal like this, here CH2, CH2 like this, CH2. So this is carbon-carbon single bond only. Definitely this is alkane. So what will be the name? Single bond, root word, 3 carbon. So root word will be prop. And because of single bond, that will be in propane. But cyclic, that's why you have to write here cyclopropane. Cyclopropane. Just we have to add cyclo. In case of butane, normal butane, but here this is cyclobutane. Hexane, cyclohexane. Pentane, cyclopentane. These are the simple cyclic. But in case of cyclic also, we have to learn through the branching also. So here, if I put one methyl group, so what will be the name? That will be methyl cyclobutane. So name will be methyl cyclobutane. Similarly, if I say, what will be the name? That will be ethyl cyclohexane. Ethyl cyclohexane. You can ask me, do you have numbering here also for this substituent? In case of only one substituent or branching, so no need to numbering. No need to do numbering. But in case of here, suppose this one, here ethyl, here another methyl. Clear? Now the numbering. So here should we start numbering. Ethyl or methyl. So 1, 2, 3, 1, 2, 3. So that is your homework. Here, this is your homework. So what will be the name, IPC name that you have to write? Clear? Okay. So what will be this name? One, two, three. So 1, 3 dimethyl cyclohexane. 1, 3 dimethyl cyclohexane. Okay. So that will be the name here. Now, if we see another example, right here. So if I start from numbering here, 1, 2. So 1 plus 2 plus 2 because of 2 methyl group. If I start from here, so that 1 and 2. So that will be 1 plus 1 plus 2. So here 5, here 4. So definitely we have to start from here. So the name will be 1, 1, 2, all are methyl. So that's why trimethyl cyclopentane. Okay. Now another example we'll see. Okay. So what will be the name? So here main thing numbering. If I start from here, 1, 2, 3, 4. Okay. One possibility is here. 1, 2, 3, 4. It means 1 plus 2 plus 4. Other possibilities, we can go like this. So that will be 1, 2, 3, 4. So 1 plus 3 plus 4, that will be 8. Here 7. So we have to start from here. 1, 2, 3, that is red color. So what will be the name? The name will be one position, that is ethyl, as a substituent, that is ethyl. Here also ethyl. So 1/4 diethyl, then 2 methyl cyclohexane. So that way we have to practice. Now next example. Okay, in case of cyclic 3 carbon, here also 3 carbon, 1, 2, 3. Here also 3 carbon. Both are same, na? So which one will be the longest chain or principal chain? In case of both same, cyclic and acyclic. So that cyclic will be the principal chain. So here propyl cyclopropane. That name will be propyl cyclopropane. propane. Clear? If you have more than this thing, it means, let's say this example, like this. So here 3 carbon, but here 1, 2, 3, 4 carbon. 4 carbon. So definitely this portion will be the principal chain. Okay. So now that cyclopropyl act as a substituent or branch here. At which position? So numbering you have to start from here. 1, 2, 3, 4. So 1 cyclopropyl, 1 cyclopropyl butane, that will be the name. Okay, now tell me what will be the name of these two compounds. So here 2 cyclopropyl attach in this carbon. It means we can say this is the derivative of alkane. So here we have to write dicyclopropyl methane, dicyclopropyl methane. This will be the name. In case of here, so 1, 2, 3, 4. So this is butane. Which position? The 2 cyclohexyl groups, first position and fourth position. So 1, 4 dicyclohexyl, because of 6 carbon substituent hexyl butane. Okay, 1, 4 dicyclohexyl butane. If we have one cyclic, acyclic, that time we have to check where the number of carbon is more, that will be the principal chain. But in these cases, no need to check which one will be the principal chain. Definitely, this will be the principal chain, this will be the principal chain. Because these are the derivative of alkane. So always substituent act as substituent, here also substituent. Although the number of carbon is more than this 4 carbon, but here act as a substituent. So that way we have to practice. Thank you.